private networks, like in oil and gas, utility, really to improve their efficiencies and connecting the workforce and the machines. Next, I'd like to invite Mr. Prabjot. So moving from the radio to the core again, I would say, or the cloud solutions, we have Mr. Prabjot, who's VP Engineering at CoreEdge IO, heading product development and Cloud Compass platform. He's worked extensively in domain of orchestration, SDN, traditional routing switching platforms, providing solutions using various open source projects. Prabjot has extended his services to the community as chairperson for Tungsten Fabric Steering Committee, contributions to Linux Foundation Networking White Paper, and Solution Showcase using open source projects. He'll be sharing our views on 5G evolution, cloud-native technologies enabling network and infrastructure automation. Over to you, Prabjot.
Yeah, thank you. Good afternoon, everyone. So we at CoreEdge have done a lot of work around enabling cloud-native technologies, not just in the core infrastructure, but also at the edge. Thank you. Also at the edge, as we are already talking about edge cloud, right? That is going to be one of the major piece of the requirement to really deliver end-to-end capabilities that we are talking about with respect to the 5G overall solutioning, right? Let it be Mac or some of the other pieces that we need to address. And that's where infrastructure is going to become a very important piece. And what we believe cloud native technologies can enable all of these in a very easy manner, enabling automation on not just on the infrastructure, but also on the network interconnects, the way all of your services are going to function together and deliver the overall 5G experience for the consumers. So before getting into this, right, so what is essentially cloud native, right? So many times this term gets confused and interpreted in different manners. So essentially from the perspective from where we are coming from, it's more of taking advantages of distributed compute that is being offered by your infrastructure and enabling automation of how these services are going to be rolled over and perform together, irrespective of which server it goes on to and how it actually functions together, right? So you might correlate this with a lot of the capabilities that your public clouds are offering you to you already. So that's what we are talking about with respect to cloud native. And essentially the idea here is that we are looking forward to bring independence, resiliency, some sort of standard-based interoperability with the workloads, and even agility and automation where expectation is that there will be no downtime. So when we talk about all these expectations, one would assume that, okay, the service has to be up and running almost 100% of the time to really give you a very good user experience in the to begin with, right? But this is where, when we talk about cloud native technologies, they differ. They said you plan for failure, and so it's okay to have failures, but you should have a fallback plan. So when it fails, how your service should continue to be provided. Irrespective of whether a single individual application or the microservice is still up and running or not, your service impact should be minimal. And that are the concepts on which this whole platform and thought process is built upon. And this underneath, of course, uses the open source technologies like OpenStack and Kubernetes, but they just form the foundation and the basis of it. That in itself does not really takes you where you really want to be with respect to cloud native automation of infrastructure and network interconnects. So here, I'll just flash this for the reference. People might already connect with it. So we are taking a reference of 5G core deployment, which already defines a lot of pieces as per the 3GPP standard, and talks about how this needs to be connected, right? And many of you might realize this is already either containerized or virtualized pieces that you are already deploying as part of your 5G rollout that is going to be coming soon, right? As we were discussing, that is already knocking on the door. But the point is how we go further ahead is going to be very, very important, right? Leveraging these things ahead of the time, bringing in some sort of automation and expecting how you are going to cover the scenarios when the load on the network increases, when you need to deliver a huge amount of data, you need to serve huge number of users. Today we are only talking about human users, but 5G is set to roll out a lot of devices that are going to be onboarded onto the network to deliver use cases like V2X, to deliver use cases like some of the smart city projects that would be enabled, to deliver use cases on MEC, right? So to enable all of that, there will be a huge requirement to replicate these things and keep on having multiple instances of it being deployed and then serving the purpose for it. And just taking a little bit further into perspective, just deployment is not enough. Now, you initially might begin with, okay, my 5G network would be a continuation from what I have been doing from in my 4G network, because that gives you a leeway to switch the technology and still deliver the similar experience with managing pretty much the infrastructure the way you are managing it today. So that is your probably the first use case that you might look at, right? Where you're just doing a local offload where the UPF is going to sit on the edge, but most of the core is still centralized, managed in one of the regional data center or a place where you're going to manage your users, you are going to take care of how your AMF and other packet core functions would behave. But the moment you go further down, where you might have locally administered edge or even the autonomous edge, the requirements just keep on getting complex and complex going further, right? And it's not easy to envision how you are going to use OpenStack Kubernetes the way you are using it in your data centers at your edge. And that becomes very big challenge the moment you start including edge and talk about how edge cloud would help you. So these challenges, there are of course challenges, right? And this is, I mean, easy to say, everyone will talk about it, but how to really bring it into action is critical. And as I was pointing out at the edge, you can't expect to have all these skill sets on diversified independent locations to have people, I mean, this itself is difficult to do it in a data center itself. I think most of the operators would probably agree that you can't have expertise on all of the features or all of the capabilities that I have been listing over here. And the problem to certain extent even expands, right? And questions whether it's even feasible to do it at the edge, right? And that's where most of the public clouds like Google, Oracle, AWS and Microsoft are already trying to collaborate with the telcos to figure out the right solution for the edge, right? And in fact, even for some of the IoT solutions which they have done, they are trying to position it if they can solve some of the telco problems. But to our understanding, it's still too early to really accept them as the only way to go ahead, right? Because they are not really designed for telco-oriented operations. And even if you look at the core part of it today, so similar requirements are there. So telcos are pretty much limited with two options. So either they leverage public cloud infrastructure, which somewhere leads to a larger cost of operations, and at times you may want to choose multiple clouds instead of relying on just one. So probably all of you are aware of the incident that happened with AWS, and you can't expect a downtime for your subscribers when you're leveraging these public cloud infrastructures, right? You try to diversify your investments over there. And then comes the legal aspects also. So for data sovereignty and the control which regulations might enforce on you on where the data should be going. And then the second option is that you improve your infrastructure itself, that it gives you a hyperscaler kind of capability and functionality, right? Now, I don't see the public cloud vendors, probably it's not as part of their business strategy, right? It's not of their interest to enable others to set up equivalent data centers or public cloud infrastructure, right? Because it becomes a competition. But from a 5G rollout perspective, you will require some sort of core where you want to have equivalent capabilities, so you can manage your infrastructure to certain extent and give a best solution that you would require, right? Equivalent to what capabilities your hyperscalers are providing you as of today. So Continuing a little further, so this is one of the project which Google has seeded in collaboration with the Linux Foundation. And this is where the public cloud vendors and the telcos are trying to come together to solve this problem. And essentially the idea is to enable cloud native technologies in certain mechanisms so that your infrastructure, your Kubernetes as a platform, and over and above your network functions that are coming from 5G can be automated and managed with a intent-driven and event-driven mechanism which Kubernetes is already providing. So having said that, this allows you to do a lot of things, and Google, as per their statement, they are already leveraging it and using it in their business process offerings. And this is supposed to simplify a lot of stuff, but it still does not capture how you are going to address the edge scenarios, because the problem remains same, right? You need to have a unified, centralized management on the distributed infrastructure, and over and above you need to have automation on how your workloads will be deployed and connected to each other. And that's where the work that we have been doing comes to help, where so we provide a edge and cloud platform. So you can read it as edge cloud or edge and cloud, because we do both, where we have two products, Cloud Compass and Cirrus Cloud Platform. Cirrus Cloud Platform helps you build your own public cloud equivalent hyperscaler kind of environment on your data centers, which gives you all the automations you required with respect to spinning up your infrastructure components and connecting them together. And Cloud Compass gives you an overarching umbrella where it brings edge also into perspective. So no matter the geography of your infrastructure, no matter how far it is located from your data center, it makes sure all those infrastructure comes and work as one layer for you. It becomes a platform on top of it. So as part of our offering, we give you infrastructure management, multi-cloud orchestration, and a uniform layer of identity access management, giving a uniform role-based access as well. And all of these assumes that the underneath infrastructure remains same. So we do not expect you to bring in a new infrastructure to really do all of these items, but we enable your existing infrastructure over and above, and all the applications fits directly into it, and the data sovereignty is also retained by the virtue of that your data lakes will be the ones which are going to be fed with this information and analytics details that whatever this platform is being generating. So I'll keep it short. We do have a booth outside. If this interests you, we can discuss further. And of course, thank you. Thank you for your time.
Thanks, Prabjot, for bringing the need for